Hello, good evening to all of you. I hope all of you are doing well. So, in today's class, we are going to discuss what is model, what is modeling, and why is model required. So, model basically is a representation of concepts and relationship between them. So, by concepts, what we are trying to refer to is we are trying to refer to entities. So, if we consider an example, teacher teaches a student. So, here teacher and student both are models, and they are related by the fact that teacher teaches a student. So here teaches is the semantics. So that is the way how what we try to do is we try to establish relationship between various concepts that are there pertaining to a system, right? Now a conceptual model in case of computer science is also referred to as domain model. Now a domain model or a domain object model is is a conceptual model pertaining to a domain of interest. Okay, so it's a conceptual model pertaining to a domain of interest. So it describes the various attributes, the various entities, the attributes, and the relationship, plus the constants that are governing the integrity of the model. So whenever we talk about a domain model is nothing but a conceptual model pertaining to the domain of interest that describes various entities, their attributes, their relationships, and constraints that are governing the integrity of the model. Now, what is modeling? Now, modeling is a representation or simplification of reality. So here, what we try to do is we try to create an abstract representation of system that is very easy to understand. So modeling is basically a mechanism for creating an abstract representation of system for effectively managing complexity as well as for simplifying understanding of the system. Now, it provides a blueprint for creating system. Now, there might be a question that why we need to build models. So model facilitates better understanding of the system to be developed. It describes the structure as well as behavior of the system. It explores multiple solutions for providing or for enabling selection of appropriate solution for the problem. It furnishes abstraction by managing complexity. It documents major design decisions. It visualizes system as is and to be, and provides a template for constructing a system. Now, it provides better understanding of the system because it tries to reflect only those aspects that are important for understanding of a particular system, and it subsides all the unnecessary facts about the system that is not required for understanding of the system. So it creates, you can say in a very simplified term, it creates an abstract representation of system that is very easy to understand. It describes both the structure and behavior of the system because in case what we have is we have models that can discuss that can describe the structure as well as model that can describe behavior. For an example, a class diagram is a model that represents structure. A state diagram is a model that represents behavior, right? It tries to provide multiple solutions to the problem, and then by analyzing multiple solutions, what we can do is we can select appropriate solution for the problem. It furnishes abstraction by managing complexity. Here, just see what we try to do is we try to emphasize on representation of limitation on the representation of information content. So in order to enhance understanding of the system, what we tend to do is we tend to perform abstraction, which in turn helps in managing complexity. It documents major design decisions. It visualizes system as is and to be. That means what is the system as of now and what is it expected to be after development, and it provides a template for creating a system. Now there are certain modeling principles that you need to follow. So modeling principles, the choice of the model affects how a problem is tackled. So how suitably a model is selected for representing the various aspects of the system dictates the way how the problem is solved, right? Now every model may be expressed at different levels of abstraction. Effective models are always connected to reality, and no single model is sufficient to describe a non-trivial solution. So these are the fundamental modeling principles that we have. So the choice of the model affects how a problem is tackled. Every model may be expressed at different levels of abstraction. Effective models are connected to reality, and no single model is sufficient to describe non-trivial solution. Now, let us try to understand what is UML. So, UML basically stands for Unified Modeling Language. It is the language used for visualizing, specifying, constructing, and documenting artifacts that are intensive to software systems. So it is not actually a programming language, but it's a mechanism for visually representing, specifying, constructing, and documenting artifacts regarding software-intensive system. But some of the platforms like Umbrello, in case of Red Hat, allows us to take in the design of our software system, and it allows us to build up a executable program for the various representations that we have created. So to be very clear, so it's not a programming language, but it's a language for visualizing, specifying, constructing, and documenting artifacts of software intensive system. Now UML has evolved as a unification. It's called as unified modeling language because it was evolved from unification of three different types of representations of our object-oriented system. One is called as OMT by Rambach. Okay. Second one is called as Boots model by Grady Boots, and then we have OOSC by Ivar Jacobson. So these were the three concepts or representation mechanism of object-oriented system that were integrated together in order to form unified modeling language. So that's the reason why it's called as unified modeling language, because it is formed after unification of OMT, Boots, and OOSC. Now, UML is a specification language, or unified modeling language is a specification language that provides view for deployment and development. UML is independent, and UML is recommended for use for the processes that are use case driven, architecture centric, iterative, and incremental. So UML provides view for deployment and development. UML is process independent, and UML is recommended for the use of the processes that are use case driven, architecture centric, iterative, and incremental. Now, what are the goals of UML? So, the major goals of UML is to provide modelers with an expressive visual modeling tool that enables modelers to represent the system both in structural as well as behavioral dimension. It provides extensibility and a specialized mechanism to extend the core concepts. It supports specifications that are that are rather independent of particular programming language and development process. It provides a basis for understanding specification languages, and it encourages the growth of object-oriented tool in the market. So these are the major goals of UML. So the prominent goals are to provide modelers with the expressive mechanism of representing the structural and the behavioral aspects of the system in terms of model. It is a extensive. It provides extensible and specialized mechanism for extending the core concept. It supports specifications that are independent of a particular programming language and development process, and it provides the basis for understanding specification language and encourages the growth of object-oriented tool in the market. Now, let us try to understand UML building blocks. So, UML basically has three building blocks. These are called as elements, relationships, and diagrams. Now, elements are capable of elements basically represent citizens of the model, and these are capable of expressing structure, behavior, grouping, and annotation, right? So elements are the citizens of the model. This may be structural element, or it can be behavioral element, it can be grouping element, and it can be annotation element. Now relationship ties the elements together. So these are capable of establishing relationship between various elements. Diagrams are mechanism for grouping the mechanisms for grouping the elements and relationship. So it's capable of representing the various elements as well as the relationship between them. So there are three basic building blocks of UML. These are elements, relationships, and diagrams. So elements are the citizens of the model. So relationship ties the elements together, and the diagrams are capable of expressing the elements as well as their relationships. Now there are four types of elements in UML. These are called a structural element, behavioral element, grouping element, and annotation element. Now structural element basically tries to describe the structure structural aspect. Behavioral element basically tries to describe the behavior of the system. Grouping element tries to package everything together. Annotation element tries to associate meaning with the various components of structural, behavioral, and grouping elements. So till now, what we have learned? We have learned that UML is a specification language that provides view for both development as well as deployment. It's process independent, and it's basically recommended for systems that are use case driven, architecture centric, iterative, and incremental. Then we try to identify the goals of UML, and then we discussed UML building blocks, and we came to know that there are three basic building blocks of UML. These are elements, relationship, and diagram. Elements are the citizens of the model. Relationships are relationship ties the elements together, and diagrams are a mechanism for representing the elements in the relationship. Now we have learned that there are four types of elements. These are structural element, behavioral, grouping, and annotation element. Now structural element. Now structural elements are the static part of the system. Static part basically means something that does not change with time. So structural elements are the static part of the model that represents conceptual elements, and these are nouns of the models. So structural elements basically refers to static part of the elements that do not change with time, and these are nouns of the model. Now there are seven static elements. These are classes, interfaces, collaboration, use cases, active classes, components, and nodes. So there are seven structural elements, namely class, interface, collaboration, use cases, active classes, components, and nodes. Now classes. So let us try to understand class. We've been discussing class since a long time. So class is a description of set of object that has same set of attributes, operations, and relationships. Okay. So this is very much important. So class is a set of object that shares same attributes. Operations, relationships, and semantics. It implements one or more than one interface. So interfaces are basically services that are provided by the class, and graphically it's rendered using a rectangle including name, attributes, and the methods. And it can also be used to represent actors, signals, and utility. So class is a description of set of objects that share same name that has same set of attributes, relationships, and semantics and operations. It's the implementation of one or more than one interface, or implements one or more than one interface. That is the services that are rendered by the class. And graphically it's represented with the help of a rectangle using the name, attributes, and operations. So in some of the representation you may find class in a complex represented in a complex notation as well, where name is present and attributes and operations are hidden. Now interfaces. Now in interfaces are basically collection of the operations that specifies the services of a class. So whatever services that are provided by a class to the external users are what are highlighted in the interfaces. Now interfaces basically represents externally visible behavior of a class, right? Partial or complete. Now it defines the set of operation signature, but does not disclose the implementation. So whenever we talk about interface, so interface represents services that are provided by the class, but without its implementation. So graphically, it's rendered using a circle. So that is the distinction between a class and an interface. Now let us try to move on to collaboration. Now collaboration basically represents a set of elements interacting with each other in order to realize a particular behavior. So the collaboration basically discusses the interaction between various elements. Several elements cooperate with each other in order to realize a particular behavior. Now it includes both structural and behavioral dimension, because you see, whenever a behavior is to be realized, then the number of and the number and type of the object involved in realizing the business never changes with time. So, for an example, issue of book is a scenario that may be there in case of library management system. So for issue of book, same number of objects and same types of objects will be involved every time whenever the behavior is realized. So collaboration is the only representation in case of UML that exhibits both structural as well as behavioral dimension or behavioral aspect. Now it represents implementation of pattern of cooperation that makes up a particular system. Definitely, so it shows the way how the elements interact with each other in order to realize a particular behavior. But here again, I'm emphasizing on the term that collaboration is the only representation in UML that exhibits both structural and behavioral aspect, because the number and type of object involved in realizing a particular behavior will never change with time. Now it is represented with the help of a named ellipse with a dashed line. Now, use case basically describes a particular way in which a system can be used by a user. And if I want to refer it to our use cases, so use cases are all possible ways in which a system may be used by a particular user. So, in a singular instance, it's a particular way in which a system can be used by the user. Now, uh, in order to realize the use case, what we need to have is we need to have a set of elements collaborating with each other. So it also is realized with the help of collaboration, because set of objects collaborate with each other in order to realize behavior. So it is used to structure the behavioral element in a model. Now graphically, it's rendered using an ellipse with a solid line. Now active classes are classes which has objects with more than one, or which can manage more than one processes. So that can be done through threads. So if an object of a class has multiple threads, then the class is called as an active class. So a class whose object has concurrent behavior with other objects called as an active class. So it can also be used in order to represent process and threads. So graphically, active class is rendered just like a class but with a thick line. Now components. Components are physically replaceable part of the system that conforms to or provides realization of set of interfaces. So now whenever we are trying to represent system that are distributed in nature, so a distributed system can be represented as a collection of components where each component has in it a set of interfaces that realizes the behavior of the class. So components are physically replaceable part of the system that conforms to and provides the realization of set of interfaces. Now it represents deployment components such as Java Beans in case of Java, right? So components represent physical packaging of logical elements such as classes, interfaces, and collaborations. So it can be used in order to represent applications, files, library, pages, and tables. So this is what is components. So a physically replaceable part of a system that conforms to and provides a realization of set of interfaces called as a collaboration. So it represents physical packaging of logical elements such as classes, interfaces, and collaborations. Right now, so now let us discuss what is a node. So node is a physical element that exists at runtime. It basically a node is basically a location where components are deployed. So a node may have more than one component placed in it. So it also represents computational resources that are required for a component in order to perform action. So component may migrate from one node to another node, and graphically it's modeled using a queue. So so this is what is a node. So node is a physical element that exists at runtime. It's capable of representing computational resources with memory and processing capabilities, and a set of components may reside in a node, and component may migrate from one node to another node, and graphically it's modeled using a queue. So these are the description of 7 structural elements that we have. But here what I want to emphasize upon is I want to emphasize upon these two components that are called as these two elements that are called as components and nodes. So components and nodes are only applicable in situation when we are talking about distributed systems, because in case of monolithic system, the entire system is deployed in one location. So here component node does not come into picture. But whenever we are talking about distributed system where different components of the system are located at different places, so component and node comes into existence. So these are the 7 structural elements that we have. We have class, we have interfaces, we have collaboration, we have use cases, we have active classes, we have components, we have nodes. So let us revise it again. So class is a structure of the object. It describes the set of attributes, the relationships and the semantics that belongs to a particular object. So it's graphically rendered using a rectangle with class name, attribute list, and methods. In some situations, the attribute list and the methods may be compressed. Interfaces, it renders the services that are belonging to the class or the externally visible behavior of a particular class. An interface is represented with the help of a rectangle. Then what we have collaboration. So collaboration represents the interaction between various objects, in order to realize the desired behavior. But collaboration represents both structural and behavioral aspect. It represents structural aspect because the number and the type of the objects or elements participating in realizing a particular behavior does not change with time. So it is the only representation in UML that exhibits both structural and behavioral aspect. Then we have use cases. Use case is a particular way in which a system can be used by the user, and use cases basically represents all possible way in which a system can be used by a user. The active classes are classes whose object has more than can manage more than one processes or have multiple threads in it. Components are physically replaceable part of the system that realize a set of interfaces. Nodes are the places where the component resides. So now let us move on to the behavioral aspect. So behavioral aspect represents verbs of the model. So it is something that changes with time, right? So there are two types of behavioral aspects. One is called as interaction, and the other one is called as state machine. So interaction diagram. So what we have is we have examples like sequence diagram, right, and collaboration diagram that's capable of representing interaction between various objects that takes place whenever a business is to be realized. So interaction basically represents a set of messages that are exchanged amongst the object of interest at a particular context in order to accomplish a specific goal. So interaction basically represents a set of messages exchanged between the set of objects that are involved in realizing a particular behavior or accomplishment of a specific goal. Now it specifies the behavior of set of objects. That's what we've discussed. So it involves number of other elements like messages, sequence of action that takes place whenever message communication is there, and links that are communication along which the exchange of messages takes place, and graphically it's rendered using an arrow. So this is an important aspect that we need to remember, that whenever objects interact, they interact by exchanging messages, and in order to accomplish a particular goal or attain a particular objective, what they do is they exchange a sequence of messages, and it involves exchange of messages between a set of objects. So it involves messages, it involves action sequence, it involves links. Okay. So messages are the context that is communicated between the various object. Action sequence is a sequence of steps that are taken into consideration whenever or a sequence of steps that are executed in order to realize a particular behavior, and the links are the channels through which the interaction takes place, and graphically it's rendered using an arrow. Now state machine. State machine is a sequence of states that an object attains during its lifetime, right? So if an example, a student, if he enrolls into a course, so if there are 8 semesters in a particular course, so a student migrates between different semesters at different point in time. So a state basically represents a sequence of states that the object attains during its lifetime. Now it may specify the behavior of an individual class or collaboration of classes. So the transition of the state may take place because of the action that is performed by other set of objects belonging to an individual class or a collaboration of class. So it includes number of elements such as states, transition, events, and activities, and it's presented using a rounded rectangle with the name and name of the state, and if possible if there are substates, right? So this is what is the behavioral, what are the behavior elements. So we have two behavioral elements, we have interaction and we have state machine. So in today's class, if you see, what we have learned about is we have learned about what is model, We have learned about what is modeling. We have learned about why do we need a model. We have learned about UML as a mechanism for specifying, visualizing, constructing, and documenting software-intensive system. We have learned about why it's called as a UML because it's formed after unification of three concepts related to object-oriented software development paradigm, related to Rambach, Booth, and Jacobson. So it's not a programming language, but it's a mechanism for specifying. So UML as a specification language provides view both for development and deployment. UML is process independent, and it's recommended for a system which is use case driven, architecture centric, iterative, and incremental. And we have listed a set of goals of UML. Then we discussed about the various UML elements, and we have discussed about the seven structural elements, and we've discussed about two behavioral elements. So in the next class, we're going to discuss about the annotation elements and the grouping elements. Thank you very much.